another triangle problem with cars. Okay, cars are 1,000 miles apart from each other. Car A is east of car B. That's where they start. So now car A is traveling more east. So again, I'm not going to label that A. I'm going to put this as A. So that's the distance that A is traveling. And we know that car A is traveling at 50 miles an hour. So dA over dt is 50. All right, what's car B doing? Car B is traveling south. So this looks pretty good right there. So dB over dt is 40. Right, so now what do? What are we trying to find? Still trying to find the distance between them changing. So I'll give that C. So find dC over dt. And what's the when? The when is 3 hours. So when is t equals 3? Okay, let's put together our equation. So we've got c squared equals b squared plus, okay, this is the tricky side, it's going to be 1,000 plus a all squared. Now I'm ready to take the derivative. So I get 2c dc over dt, 2b dB over dt, plus 2,000 plus a, and then to the 1 power, derivative of the inside, dA over dt. Whew, okay, let's figure all these things out now. So I've got t, well, first off, let's get rid of those 2's. Okay, t is 3. So if t is 3, and I'm looking at b here, b will be 40 times 3, so that's 120. So I get 120 times the rate of 40 plus, okay, let's look at what we've got here. A is moving at 50 miles an hour, so this distance A will be 3 times 50. Whoops, sorry, I'm thinking 2 things at once. 3 times 50 is 150. So I'll put the 150 in for the A, carry the 1,000, and then I multiply by dA over dt, which is 50. All right, and then so let me just carry c dc over dt. So let me just write what I have here. So this side here, right, I'm talking about this side, would be 1,000, 150. Whoop, I wrote that wrong. 1,150. 1,150. This side length here is 120. So to find the C, right, to find the C, I'm just going to take liberties here and put it in the denominator. So that would be the square root of 120 squared plus 1150 squared. Positive number because it is growing. All right, last one. So a baseball diamond truly is a square that's shifted over. So that's the home base. There's first and second and third. Each of these sides is 90. Okay, so it's a square. So a batter hits the ball and runs toward first base. So I'm going to put the batter here, person running, and this is the rate they're running. So I'm going to give that length right there the letter B, and dB over dt is 15. So that's increasing, right? It's getting bigger. At what rate is the batter's distance from second base growing? So that means they want us to find that thing. So I'll label it C. So find dC over dt. And you know that this is a right triangle, right? Because it's a square. We're just looking at it as a diamond. All right. So what do we have here? Let's think about this side here. All of this is 90. And then I've got this B going on. So what would the length of that side be? The length here would be 90 minus B. So thinking about my equation, I've got the hypotenuse, C squared, equals 90 squared, this one, plus, oops, that's supposed to be a 90, 90 minus B all squared. Okay, I'm ready to take the derivative. So let's do it. So I get 2c dc over dt. Derivative of 90 squared is 0. 2. 90 minus b to the 1 power. Taking the derivative of the inside gives me negative db over dt. So let's cancel those 2's. Oh, and I forgot to identify what the when information was. When the ball player is 50 feet from home base. So let's think about that. 50. I think that means when this is 50. Can't use it until after I'm done with the derivative, but wouldn't that mean that 90 minus b would be 50? I think that means that. So I get 50 negative 15, right? Because that's the rate. And then dc over dt. And then I just need to find what c is equal to. Okay, so let me just draw the picture again. So here's 90. This would be 50, right angle. And there's c. You can see that c is 90 squared plus 50 squared. And there we have it.